So here's some vocabulary terms. So here's what we're going to do in this section. It says, find and combine like terms. So I have this like cloud of terms, and I'm going to start here with the 9. What out of all these terms could I combine with the 9? 4. What else? And negative 3. All right, so that's all the like terms that go with 9, and here's how I would combine them. I'd add them. 9 plus negative 3 is 6, plus 4 is 10. What about, how many things are like terms with 5xy squared? Negative xy squared. What else do you see? Xy squared. Now, these other terms have x's and y's in them, but what's different? And how come those aren't like terms? The exponents are different, right? The squares are in different places. And so those green things that I just boxed, those are like terms, so they can be combined, which means we're going to add them. Now here's the thing, when you're adding or subtracting stuff that has variables and exponents. Oh, sorry. I was like, I had no idea why that was funny. I was like, I don't even know what was funny. Okay. I was like, what is funny? I just said math. All right. You are doing the math only on the coefficients. Okay? So it's this 5. What's the coefficient here with that negative? What does that really mean? It's a negative 1. And what's the coefficient on that third term? 1. So you're just doing the math on those because you're saying, how many xy squareds do I have? I have 5, and then when I take a negative 1 away, that gives me 4, and I add 1 back in, it gives me 5. So I have 5 xy squareds. Notice I didn't change the exponents at all. You only change the exponents when you're multiplying or dividing. When you're adding or subtracting, it's kind of like you're saying, I have 5 oranges, except instead of an orange, I have xy squared. I have 5 of these things, negative 1 of them, and a positive 1. How many of those things do I have all together? Is 5. Okay, and the thing happened to be the xy squared. Okay, so let's look at the next like terms. Negative x squared y. What is a like term with that? How many things do you see? 2x squared y and 3x squared y. So I'm going to combine those by adding them. True or false, I'm also adding up all the exponents. False. Way false. That's so false. Very, very, very false. So I'm only doing the math on the coefficients. That's a negative 1. So 2 plus 3 is 5, minus 1 is 4, and 4 what's? X squared y's. How many things are like terms with 4ab squared? How many do you see? None. What about m? None. And z? None. But here's what would happen. If you had a math problem that said combine all 3 of those things, like let's say I had 4ab squared plus m plus z. Well, if you can't combine anything, what do you do with that? You just leave them alone. Just leave them alone. There's nothing you can do, right? That would be your answer. And the reason why I'm sort of pointing that out is because sometimes what happens is people, they get it in their head. They're like, okay, nothing matches. I can't add anything. But they'll give me like nothing for an answer, like a blank. But it's not blank. It's this, 4ab squared plus m plus z. That would be your answer. You just leave it alone. Okay, so what we practiced here was finding like terms and combining them. But it was just a cloud of stuff, right? So we're going to do the same skills down here, but it's an actual math problem now, where it's set up like we normally used to seeing. So number 1 says find the sum. Sum means we're adding. So you see the addition between the 2 groups, the 2 polynomials. So you are going to only combine things that are like terms. Now, if your brain works left to right fine, then you can go ahead and start adding stuff right here. I, though, like it vertical better. So what I like to do is take each of these terms and write them below here, lining up the like terms. So for example, I would put 4y squared under the 7y squared, negative 8y under the negative 2y, and then negative 7 under the 9, and then I would just add them. So it's whichever you like better. And so on number 1, it said find the sums. That means adding. Number 2 says find the difference. Difference means we're subtracting. In this particular problem, though, it's coming from this subtraction right here. We're finding the difference between this group of things, this polynomial, and this group of things, that's polynomial. So what am I going to tell you to do with that minus that's right there? What do you think I'm going to say? Yeah, that, with the finger. What's that? Distribute. Okay? So I want you to distribute the minus sign into the second group of things, all right? So it's going to go in here and in here. Remember, both of those are being subtracted, so both of those get the opposite sign. So I'm going to do that in a different color. This becomes plus, and 2w squared becomes negative, and negative 4 becomes positive. And what I'm going to do now is just write those under the first group, because I like to do it vertical. You do not have to. But if I'm lining stuff up and down, this negative 2w squared is going to go under what in the first group? Where will I line that? The 9w2, right? So negative 2w squared is going to go here. And then this positive 4, I change the sign to positive. Where am I going to line that up? With the 5, absolutely. Okay, so now I combine. This gives me 7w squared. What am I combining with the negative 7w? Nothing, so I just bring it down. Okay, it doesn't go away, it just comes down. So negative 7w, and then 5 plus 4 is 9. Right here, 9w, 9 minus 2. And I got that minus 2 from doing distributing the negative into the second group. Okay. Anybody need this up anymore? Oh, this is a joke. What do you think? What do you think this is? It's a trinomial, yeah. 3 nomes, it's a trinomial. It's not bad. It's not bad. All right, turn and talk. Ariana thinks that the sum 6y squared plus 5y to the 4th is 11y to the 6th. What is wrong with her reasoning? You two talk. And you two, and then you three. Take a moment while I do attendance. Almost, not yet. Okay, so what did y'all come up with? Why is she wrong? What did she do wrong? She added the exponents, right? Yeah, you can't do that. You can only add exponents how could we change that, and then we would add the exponents. We change if it was multiplying, which we're going to talk about multiplying tomorrow. So what actually is the answer to 6y squared plus 5y to the 4th? That is it. That is it, right? You can't change it at all. So that would be the answer right there. You can't combine them because they're not like terms, right? They have the same variable, but not the same exponents. Okay, sorry, Ariana. All right, so here's what's happening on this page. Number 5, there's a question like this on your final exam, but the way it's written here really is tricky for students. So what I'm going to do is build you up slowly to that problem, all right? Number 3, when 5 is subtracted from 9, what is the difference? What would you tell me the answer is? It's 4, okay? It's the from part is the tricky thing. What math did you do to get 4? 9 minus 5. It's just backwards, right? So the 9 gets written first and the 5 gets written second. And when you have this word difference, that means the answer when you subtract, okay? 4 is the difference, right? So if I was real quick just talking about 5 again, the most common mistake is to just take this group of things minus this group of things. And you see how that's not right? Okay, but the reason why it's tricky is because our brain gets number 3 easily. Boom, 9 minus 5. But once you start throwing the variables in, we're like, whatever, just going to subtract them in that order, okay? So the subtracted from part throws stuff off. So working still up a little slowly to number 5. For number 3, we did 9 minus 5. Number 4, I'm subtracting 3x squared from 9x squared. What am I going to write down?
6.
Not, but for the math part, before the answer. Right. Right. 9x squared minus 3x squared. And then, Maggie, what's the answer? 6x squared. Okay. So number 3, we had just numbers. And number 4, we have numbers with the same variable. But in number 5, we're going to layer it up even more. We have an entire group of stuff, and we're going to do minus an entire other group of stuff. What's the first group that I'm going to write down, though? Okay. And I'm going to subtract the second group. But please notice how I'm using these parentheses to group all of it together, because all 3 of those things is going to be subtracted. So I have to take that, minus sign and do distribute, right? So it's going to distribute it through. So this becomes negative 2x squared, negative 5x, and plus 7. And what I'm going to do is write those under the first group vertically, just because I like that better. You do not have to do that. So negative 2x squared plus 5x plus 7. So that's I've got 1x squared here minus 2 is a negative x squared. Oh, wait, that's a negative 5x, I'm sorry. So that's negative 9x and then plus 16. Okay. So really the only tricky part there was getting the order correctly when you subtract. And then after that, you just have to keep your signs correct and combine like terms correctly. But like I said, the thing about that makes the spring final exam so hard to get everything right is, like, let's say you did the order reversed, but everything else you got right. Well, you just don't get any points. Oh, I hate that. So that's why it's hard to pass the spring exam. All right, number 3. So we're going to move into some geometry ideas. Find the perimeter of this triangle. Perimeter means you're doing what with all the sides? You're adding them, okay? So we have these 3 sides, a, 2a minus 1, and a plus 3. You might be like, but I don't understand. I mean, shouldn't it be like 15 and 12 and like actual measurements? That's okay. It doesn't have to be an actual measurement. We're just practicing adding polynomials. So we just add them up. We have a. We're going to add up another side, 2a minus 1. We're going to add up another side, a plus 3. And all we do is look for like terms. Each of those sides has an a, so when you add up all the a's, what do you get? How many? 4. Because I have 1 here, 1 here. So I've got 1a plus 2 is 3, plus another one is 4. So I have 4 a's altogether. And then the constants. The constants are 3 and negative 1. What does that give me? 2. And there's one other piece I'm missing where I wouldn't get full credit on the final. The units. Yeah. So always put units. Because on your... Well, on the final exam, you get 1 point you get a portion for the answer and a part for the units. So even if you got the answer wrong, but you gave units, I can get you 1 point for the units. Right. You try number 4, please. Take a minute and do number 4. After number 4. So what we know about opposite sides on a rectangle is that they're the same. So we know this is 4x squared minus 8 here, and this is 3x squared here. So perimeter means we're going to add all of those things up. So You can do that one of two ways. Here are the two most common ways. The first most common way is to say, all right, I need 2 of the 3x squareds. And I'm going to add 2 of the 4x squareds minus 8. Right? Just multiply each one by 2. So that would give me 6x squared. And then distributing this 2 gives me 8x squared minus 16. And then I would combine these two things and get 14x squared minus 16 meters. Right? You want to put your units. The other most popular way of setting it up is not to do the times 2 part, but just write out all 4 things. Like people might write 3x squared plus 3x squared plus the 4x squared minus 8 plus the 4x squared minus 8. Combine like terms, and they'd still get this. Okay, so that's the 2 ways people usually do that. Raise your hand if you got that right. Excellent. Let me give you your practice sheet.